हरि करना।
So it's wrap up time for this course, Intuitive Inferential Statistics for you course. Let's understand what's power and sample size, and we will wrap this up. So power and sample size are two critical concepts in statistical hypothesis testing. Power refers to the ability of a statistical test to detect an effect that exists in the population, and sample size refers to the number of observations or participants in a study. So in general, increasing sample size increases the power of a test, which means that the test is more likely to detect a true effect if one exists. However, increasing sample size also increase the cost and the time required to conduct the study. So that's the reason understanding the power and sample size is crucial for designing experiments that can answer research questions with adequate statistical power while also being feasible and efficient. So power and sample size are important concepts in statistics that are used to design and plan studies. The power of a statistical test is the probability of rejecting the null hypothesis. What's power? The power of a statistical test is the probability of rejecting the null hypothesis when the alternative hypothesis is the true. So it's influenced by several factors, including the significance level, effect effect size, and sample size. The sample size is the number of observations or participants in a study, and it also affects the power of the test. Then we have sample size. Sample size determination is important in experimental research, where it is important to have enough statistical power to detect the effect of interest. For example, in a medical trial, it may be important to detect a certain level of difference between treatment groups, and the sample size can be calculated based on the desired level of power and significance level. So there are various methods to calculate the required sample size for a study, including analytical methods and simulation based approaches. One commonly used analytical methods is the power analysis, which involves calculating the sample size based on the desired level of power, effect size, and significance level. So simulation based approach involves generating data sets under different scenarios and simulating the test statistics and p-values to estimate the power and required sample size. So these methods can be more flexible and can be account for the complexity of the study design and underlying assumptions. So overall, power and sample size considerations are crucial in planning and designing studies to ensure the study has sufficient statistical power to detect effect of interest. So to wrap up, before we wrap up, there are two types of measuring the sample size. One is simulation based, other one is analytical methods. Okay, so these are the two different types, and so one is power analysis, other one is simulation based. Analytical method is nothing but the power analysis. So we used one technique to calculate the sample in our previous course, that is intuitive sampling and distribution course. There we have done 20 minutes course, 20 minutes video to calculate the n using analytical method. You can just go there and watch how to calculate sample size and what all parameters you have to consider to decide the sample size. Okay, with this it's a big wrap up for our uh, intuitive statistical experiments and significance testing for you course. So in this we have covered A-B testing, then we moved on to the hypothesis testing, then resampling, statistical significance, p-values, type 1 error, type 2 error, then t-tests, students t-tests, multiple testing, then degrees of freedom, analysis of variance, one-way ANOVA, two-way ANOVA, F statistic, and chi-square test. Then finally, multi-arm bandit algorithm, two stochastic, and final one is power and sample size. So this is what we have seen in this course. So the principles of experiment design, randomization of subjects into two or more groups receiving different treatments allow us to draw valid conclusions about how well the treatments work. So it's best to include a control treatment of making no change, the subject of formal statistical inference, so hypothesis testing. So p-values, t-tests, and much more along these lines occupies much time and space in a traditional statistics course or text. And the formality is mostly unneeded from a data science perspective. However, it remains important to recognize the role that a random variation can play in fooling the human brain. So, intuitive resampling procedures such as permutation and bootstrap allow data scientists to gauge the extent to which chance variation can play a role in their data analysis.